Now that we know how to find our critical t-values, let's go ahead and find the full confidence interval. So just like before, instead of having just a single point estimate for that mean and using just the sample mean, we just want an interval, which is going to be more accurate. It's going to better represent where our population mean likely lies. So constructing a confidence interval for the population mean when the population standard deviation is not known using the t-distribution is very, very similar to what we did in the last section when sigma was known. So we're still going to use that point estimate as our center, and we're still going to find a margin of error, and then we're going to add or subtract that on both sides. But again, instead of using a z value, we're going to use a t value here. Now, just remember, anytime you're doing confidence intervals, this is really important to check, is that you do need to make sure your sample is random, and either the population is normal or your sample size is greater than or equal to 30. And again, this is the minimum requirement. We saw in the last section, we have a sample size formula that we could use too. So that may even tell you to have a bigger sample than 30, but this is like the absolute minimum that you need to use these formulas. So we're going to go ahead and find our sample statistics. So you need to have the sample size, the mean, and this time you do need the sample standard deviation. So those formulas are here, but you can also find those using technology like we did back in chapter 2. You're going to need to find the degrees of freedom, and you can find that critical t-value either using your table or using the calculator and using that inverse t on the calculator. We're going to find our margin of error. So again, notice it's going to be a very similar formula. And then we're going to add or subtract as well. And there is a way to do the interval on the calculator. So I'll show you that after. We'll do it by hand, and then I'll show you how to do it on the calculator too. All right, so get my notes out. We randomly select 16 coffee, sorry, I should say shops, not chops, and measure the temperature of coffee sold at each. The sample mean is 162 degrees Fahrenheit with a sample standard deviation of 10.0 degrees Fahrenheit. We're going to construct a 95% confidence interval for the population mean temperature sold, and we are going to assume that population temperatures are normally distributed, which is good because notice that my sample size is only 16 here. So I wasn't meeting the requirement of at least 30. So I need to make sure that the population is normal for me to proceed. So we're okay. We're going to go ahead and proceed. And again, we're randomly selecting. So I have a random sample, and I know that my population is normal here, so I can have a small sample size. This one's nice too because they gave us the mean and the standard deviation. If they didn't give those to you, you'd have to find them yourself. So if they gave you the raw data instead, remember you can either find those by hand or you can use that one var stats feature on the calculator that we've done before, or you can go into an Excel file and find your standard deviation and your mean that way too. So again, you have to find them by hand. I would go ahead and use technology to make those values a little bit faster for you. All right, so what I'm going to do next is I'm going to find my degrees of freedom is going to be 15. So again, it's 1 minus your sample size. And I do need to find my critical t-value. So to find my critical t, I know that I'm doing 95% confidence, and my degrees of freedom is 15. So my critical t-value, let's go into the table here first. So here's my table for my t-distribution, and we said our degrees of freedom was 15, and we're doing 95% confidence. So there's my 95%. I'm going down to 15 here, and I see 2.131. So that's going to be my critical t-value. Now, if you want to do it on technology, so let me just make a little note here. So let's say you're doing technology. Again, the graph is still bell-shaped and symmetric, so it's similar. Your mean is still at 0, and you're looking for your two t-values. And if it's 95%, then let's use a different color. We want that area in between here to be 95%. So what happens is there's 5% missing, right? So that missing piece is going to get split. So you're going to have 2.5% go here and 2.5% go here, which gives me 100% altogether. Now, if you're using technology, you do have to find the area to the left. So you're actually looking at all of this area if you're using technology. So you have 95% plus 2.5% is 97.5%. So 0.975. So if I'm using my calculator, I'm going to go ahead and I'm going to first hit second bars and then inverse T. My area to the left is 0.975 and my degrees of freedom here is 15. And you can see there's that 2.131 that we're looking for. So you can do it that way too. Again, this is probably the one time where the table is probably going to be faster for you, but we can get the same value in either case. So our error is that critical t-value times our standard deviation over the square root of n. So I'm looking at 2.131 times, standard deviation is 10, and then my sample size is 16. And I'm just going to use my calculator here to find this value. So 2.131 times 10 divided by the square root of 16. Now that I know is just 4, but I'm just going to leave it in the regular notation. And I get about 5.3275 for my error. So we're going to round it to one decimal place, stay in line with your book. Now, remember that we're talking about degrees here. So your error is about 5.3 degrees Fahrenheit. It's the same units as whatever you're talking about. So finally, to find my interval, I'm going to take my center, I'm going to add my error, I'm going to take my center, and I'm going to subtract my error. So my center is 162 plus the 5.3, and then I do 162 minus the 5.3, and I'm running out of room here. And what I'm going to get for my values will be 156.7 degrees Fahrenheit, and then 167.3 degrees Fahrenheit. So we are 95% confident that the true temperature, the true average temperature for our population is somewhere between 156.7 degrees and 167.3 degrees. And again, this is about our confidence. So in this case, it was 95. So we're 95% confident that the true mean is in between there somewhere. Now, you can find the intervals on your calculator, and this is also very quick and easy, which is nice. It's very similar. So you press stat, test, and then instead of pressing Z interval, you're pressing T interval. So you want to be very careful. So I press stat. I'm going to go over here to tests, and then I'm coming down here. Don't do T test. I don't want test. I want interval. So I want T interval. And you're going to enter the mean, which is 162. You're going to enter the standard deviation, which is 10. My sample size is 16, and my confidence level is 90. I'm going to hit enter, and then we should see my lower and my upper limits match. So 156.67, so there's the 156.7, 167.32, 167.3. So the same values there on the calculator. So if you're doing a homework question and it just asks you to find the confidence interval and you don't have to find the critical t-value or anything like that, then you can do this very, very quickly and kind of bypass all this work and just get that answer. So technology can be really fast if you're finding that confidence interval. All right, let's do another one. So you randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot. The sample mean is 9.75 days, and the sample standard deviation is 2.39 days. Again, notice that we don't know the population standard deviation, we just know the sample. we're going to do a 99% confidence interval. And our sample here is 36 cars. So 36 cars is bigger than the 30 cutoff, so we are okay to proceed here. And again, this is a random sample, so we're fine. I don't see anything about the data being normal, but it's okay because my sample size is over that 30 cutoff, so we can go ahead and use our formulas here. All right, so I use the table again. I'll do it by hand one more time. So we're doing 99%, and our degrees of freedom then is going to be 35, so it's one less. I don't know why I keep closing the page, sorry. So we're looking at 35, which I do have 35. Let me just go down a little bit more. So there's the 35, and we are doing 99%. So I'm over here at 99, and I'm just going to match those up. And I do see it's 2.724. So that's going to be my critical T value here. So if I want to find the error by hand, I take that critical T value, I multiply it by my standard deviation and divide it by my square root of n. So I'm doing 2.724 times 2.39 over the square root of 36. And again, you're just going to use your calculator there. And let's see, what are we going to get? We're going to get about 1.09 here. I'm using 2 decimal places because they use 2 decimal places in their other calculations, so we're going to just be consistent there. So then to find the interval, we're going to take that mean and add the error. So we're doing 9.75 plus 1.09. And we're going to take the mean and we're going to subtract the error. And what we're going to get is 10.84 and 8.66. So our interval here is from 8.66 to 10.84. So we're going to estimate that the true mean for the population is somewhere between 8.66 days and 10.84 days that the car would sit on that dealership lot. And this is 99%. So we're 99% confident the true mean is in this range. Now, if you're using technology, we can do that too. So it's going to be very quick. So I'm going to just go through these steps one more time. So I'm going to press stat. I'm going to go over to test. And then again, I want T interval. My mean here is 9.75. My standard deviation is 2.39. My N is going to be 36. And my C level, my confidence level is 99. Now, one thing I will note, I didn't mention this in the last time, but see how my button has stats clicked at the bottom? So you can either have it clicked on data, in which case you're using a data set that you've entered into list 1, or most time what we're going to be doing is just having on the stat button. So all you're doing is entering those values, and then the calculator is doing this calculation here for you. So, oh, I changed my values by accident. Hang on, let me fix this. 9.75, 2.39. I was playing around with it, now everything got changed. Okay, and now I can see once I have my values back in, again, and the stats feature is selected, then my lower bound is 8.66, and my upper bound is 10.834. So here, again, with the technology here is a little bit different. You would have 8.67 if we round, and 10.83 if we round. That would be correct too. This actually would be more accurate, right? Because there's no rounding errors here compared to using the T value in the table where you have a built-in rounding error. But if you're slightly off by this, that's totally normal. And my math lab should allow for a little bit of wiggle room for technology versus table use. So just like before, I just want to do one of those examples where we work backwards. So let's say you have the confidence interval. Maybe you found it on technology or you were given it and you want to work backwards. So if you want to find the error, Again, what you're going to do first is you're going to subtract the upper and lower values. So I'm going to take that 22.1 and subtract 14.7. 22.1 plus 14.7. All right, and I get 7.4. And then what you're going to do is cut it in half. So I take that 7.4 and I divide it by 2, and I get 3.7. So your margin of error is going to be 3.7 here. And again, everything is symmetric for this case. So if you want to find your point estimate, which is your X bar here, what you can, again, one way you can do is take the upper and minus the margin of error. So I take that 22.1 and I subtract that 3.7, and I get 18.4. You can also find it by taking the lower value and adding 3.7, you'll still get 18.4, or you can find the average between these two, also gives you 18.4. So those are 3 ways that you can work backwards and find that point estimate. And the reason that works is because for normal distribution and for t-distribution, you have symmetric curves. Now, not every distribution is going to be symmetric, but we're not going to worry about that in this class. This is just an intro class. So for when you have symmetric curves like that, it's very easy to find the point estimate and the margin of error because everything's sort of centered. So you can just cut this in half and then find the average of these 2 values and you're all set. All right, so I do want to summarize a bit here, chapter 6 that we've done so far. So when do we use the normal distribution and when do we use the t-distribution? So the first thing you need to do, and I'm just going to kind of talk about this from your text, is don't forget you need to make sure you ask, is the population normal or is n greater than or equal to 30? And if the answer is no, then basically you have to stop and you can't use either formula. Okay, so you do need to make sure you do that check first, that you have a large enough sample size and that or your population is normal. So if the answer is yes, then the next question you're going to ask is sigma known? Okay, so remember this is the population standard deviation. Okay, and if the answer is yes, then you're going to use the standard normal curve. So you're using z values. If your answer is no, then you're going to use the t-distribution. So you're using, t values. Okay, so here's the big one here. So let's say you know that you can go ahead and you can proceed. The big question is sigma known? So if the answer is yes, then you're using z values. And if the answer is no, you're using t values. So that's really important to make sure you know which formula you're using. Are you using z or t? Otherwise, everything else is pretty much the same. So one last example. Let's say you randomly select 25 newly constructed houses. The sample mean construction cost is $181,000. Okay, so I'm doing n is 25 here. I'm doing 25 houses. The population standard deviation is 28,000. So notice it says the population standard deviation. So sigma is 28,000. We're going to assume construction costs are normally distributed. So we're all set here for this first check. Our size was small, was only 25, but the population is normal, so we can proceed. So this should say use. Should you use the standard normal distribution, the t-distribution, or neither to construct a 95% confidence interval? So the answer is that we're going to use the normal. And this is because we know sigma, right? Didn't we know the population standard deviation? So if you do that, then you know sigma. So you're going to use the formulas in 6.1. Okay. If your answer was to use the t-distribution, right, this means that sigma is not known. So you only know the sample standard deviation. So you're using 6.2. So the t stuff. This is the z stuff. You would say neither if n is less than 30 and the population is not normal. Again, because you can't use the formula, so it wouldn't meet the first restriction there. Or if your sample isn't random. So for our example here, because we know sigma, our answer is that we're going to go back to 6.1. We're going to use those formulas in 6.1. So instead of using t values, we can use the z values, which is a little bit easier because we know most of them already, most of the common ones. So if you know your sigma, you're going back to section 6.1 and you're using all the z values. If you do not know sigma, then you're using section 6.2 and the t values. Or if it doesn't just fit, so if your population isn't normal and your n is too small, then you can't do anything. You're going to have to go back to the drawing board and get more data. So those are our confidence intervals. And again, in the real world, you're probably going to be using that t distribution more because it's not always that we have enough population data to use a normal curve. So you just want to be careful as you're going through the questions. Most of them are set by section. So when you're doing the 6.1 homework, the questions are going to be all normal. When you're doing the 6.2 homework, they're in general going to be the t distribution, but there are a couple at the end, particularly, or middle or the end, where they do ask you which one are you supposed to use. So you want to be careful there and decide is sigma known or is sigma unknown, and that's going to help you make your choice.